welcome. So in this video we're talking about objects. Object pooling is a particular part of design, game design. So it's mostly used instead of destroying either instantiating game objects. Most times you always have to instantiate in your project, probably the enemy verbs, probably the bullets from the gun, even some effect systems. So you always have to instantiate. So and repeatedly calling instantiate and then calling destroy the destroy function, just like I'm doing here. So imagine I'm actually creating a bullet, or let's say a particular enemy. Let's say a wave of enemy that you have close to have the 100 enemies, or bullets. You have to keep instantiating bullets as much as possible. And instantiate probably 100 bullets in seconds, and then the next seconds you have to delete everything again. So Unity simply uses a garbage collection for this. But with this one is it's always slowing down. Most times it slows down the CPU, and that's the last thing you want. So you're going slowing down the CPU. So a particular mode of design is just to simply use object pooling. So it's actually used to optimize the functionality of the project and then lower the burden that you're facing on the CPU. So and it's most kind of a little bit faster than your local traditional instantiation stuff. So the way we do this is simply we create a pool of game objects. We would have instantiated that. So let me show you that. So now what we do is at the start of the game we will create a pool. So we would have instantiated enough game objects that we'll be using throughout the game. So let's say for in this our project we want to use the enemies. So we have created enough enemies that we'll be using. So Unity will have created that initially. So anytime in our game that we actually need to use the enemies. So anytime in our game that we actually have to use the enemies, what we simply do is fetch one item from this pool and then use it. And once we are done using it in this project, once the player collides with it, instead of destroying it, we will simply return it back to the pool. So in that way, we can effectively use this two number that we have instantiated as many times as possible. So instead of having to destroy it, we are simply returning it back to the pool. We are simply returning it back to the pool. So once the player's player is instead of destroying it, simply we are returning it back to the pool. So it's effective and usually saves your CPU resources, so your CPU can save better things and not it can handle better and important tasks instead of this repetitive calls of create and destroy. So basically that's what we'll be doing. So the way we'll be doing this is just like I've said, we will create a list. The list will hold the game objects that we want to create. And then at that we would ask Unity to instantiate a number of game objects. So for this our project, once the player collides with the enemy, so remember the enemy has already been instantiated here. So there are several ways you can do this, but we're following this simpler method so that it actually makes it confusing. So that's probably okay. So we actually won't be using this function here. So instead of having to destroy, we're using the object pooling there. Okay, now we'll be creating a script for the object pooling. So if we create the object pool for that start. So let me go to script, right click, create, special script. Let's have object pooling, object pooling. So I'll go from references. once we do this, that really doesn't give me a question. So if I want to attach game object in the editor to object to print enemy to path. Okay, now we need some variables. We're needing the number to print, the enemy number to print, number of enemies to print, number of enemies. So just like seeing number of enemies in instantiate at the start. So we're needing a list. Just make that is private, a private list of gameObjects. So let's call it a food object. So returning all enemy that we put enemies. So what we put enemies? Let's just so basically I think that's the base. So now let's create a function. Create unit. So what this simply is the list, the put enemy list. Set that as a new list of gameObjects, and then we start our loop that simply gets a normal for loop. So it takes in the number of enemies, it increments the value of I, and then for each values of this I, simply it means incrementing the number. We are starting from 0 and then we keep incrementing till, let me get that. So I is starting at 0, so it increments to 1, it increments to 2, 3, till it gets to this number of enemies that will be supplying here. So basically, for each one of these values, it will be creating enemies, and then adding all these enemies, adding it to a list, this list. So it will be creating this first of anytime we need it, we just hit. So the rule of doing this is we'll be setting all this. We'll be setting them to inactive in our hierarchy. Setting inactive simply means it won't be displaying in the hierarchy. So now if this one will display, it's actually there but it won't be shown. So this one will display. So anytime we need an enemy, we simply ask it to get any gameObject set that is inactive. So once it gets here, it makes it active. Once we finish using it, it returns it back here and makes it inactive again. So that's what we'll be doing. So now, using this for loop, we are going to create, let's create a temporary gameObject named enemy. You can use that anything. So what we are doing is just instantiating to the prefab. Basically that's all. And then you are setting it as inactive. So how do you do that? Just text active and then passing the boolean value false. So that's all. Okay, and then once that you now add it to this list. Remember, you have to add it to this. Put enemy, just add to the list as a method called add. So what do you want to add to this? So the same thing applies. You are creating. So this is supposed to be a semicolon. So you are creating a temporary enemy gameObject, you are making it inactive, and you are adding it to the list. So now, which means once you call this particular function at start, create enemy. So Unity would do what? Unity would create this number of enemies at start for you. So you would have those put objects there. So assuming you want 5 enemies at start, if you create 5 enemies, but make sure everything is what is set as inactive. So it won't be displayed on the scene. Now then, how do we get how do we get an enemy to use? Simply we just write a function called get an enemy. Get an enemy, get an enemy. But instead of making this void, we want to return a game object. So what do we want to do? We only have to check if a particular game object is inactive in this list. So once that game object is inactive in that list, then we will return it. So you just have to check the same thing. So just do for now. The best way to do is actually to use the for each function. So for each enemy that is in this list, we now check if that particular enemy is either active or inactive. Another way of doing this is just by using indexing. What does indexing mean? So if you have a list, if you have a particular list, it starts at index 0. So you have this one at index 0, this is 1, this is 2, and this is 3. So that's how list works. It starts at index 0. So at index 0 you have a game object, at 1 you have a game object, at 2 you have a game object, and at 3 you have a game object. So we'll just use index. So since we are already creating this I, so now what this one will do here is this particular list, where is the list? The game object, the put enemy list. So put enemy list dot if you do put enemy and you index it with 0, so it's going to get this. If you index it with 1, so you use square bracket for index, if you get this. So if you index it with 2, if you get this, the same thing applies. So now what we just do here is, I will just check if the list, I will index this, and then I will check if it is active in hierarchy. But remember, what you're actually trying to check here is if it is not active in hierarchy. If it is not active in hierarchy means what? It is currently in the pool. Remember, any game object in the pool has to be set as inactive. Anyone on the scene has to be set as active. So if this particular one is not active on the hierarchy, then that's what we want. Return this particular one. So that's it. But just as a safe bet, so return null if it can't find anyone as inactive. Sorry. Yes. Okay. So we will do a quick recap of that again. In our pool, we have game objects that are set as inactive. Once it gets to our scene, we haven't done that, but we will still do that. We set it as what? As active. So to get any game object from this pool, you have to make sure to check. That's what we are doing here. You have to make sure to check that particular thing is inactive. So if it is inactive, return it to the scene. So the way we are going to do this is we are going to come to our instantiated manager. We are going to use this script to get an inactive game object, and we are going to set it as active on our scene. If I should come to my now, to make sure that you can access this particular script without having to necessarily attach this game object to anything, it's just to create a static reference to it. So you can just do public static object to it, and then create a reference to it. So in our next video, we will be taking us through how to access this inactive game object, return it to our scene as active, and then set the location, set the position, the rotation, and other components. See you in the next one.